Edexcel Decision 1, Graphs and Networks 3, Planarity and Floyd's Algorithms. The Planarity Algorithm. A planar graph is a graph that can be drawn so that no edge meets another edge except at a vertex. So here we have a graph of the complete graph K4, and what we're asking is this graph planar? What this means is, can we redraw the graph so that the two edges in the middle of the graph do not cross? So there is an obvious one where we can draw 4 vertices around the outside. So we can draw one of the edges in the middle and then the other one around the outside. Therefore, the complete graph K4 is planar. There is also another version of this graph which is worth noting, and it looks like this. So these 3 graphs are all the complete graph K4 because they all show the same information. These are known as isomorphic graphs. So is this graph planar? So the first thing we'll want to do is draw the cycle all the way around the outside. So there are 3 edges left that we haven't included. That's the edge from A to D, B to E, and F to C. So the graph is planar if we can draw these 3 edges so that they do not cross. So first of all, let's draw AD inside, and then we can draw BE around the outside, and then we've still got FC. So either we draw FC on the inside, but obviously that crosses AD, or we draw FC on the outside, but obviously that crosses BE. So is this graph planar? No, as it is not possible to draw without any edges crossing. Being able to find planar graphs is important for things such as uninsulated wires on a circuit board. If the wires are touching, then obviously the circuit would fuse because electricity doesn't mix well and someone's going to get an electric shock, I expect. So the planarity algorithm is used to decide if a graph is planar or not. For simple graphs, it's obviously easy to decide if a graph is planar, such as the complete graph K4, by trial and improvement. But for electrical circuits and their graphs, generally they're very complicated, so we need to use the planarity algorithm. The algorithm only works if we can find a Hamiltonian cycle. Okay, so the planarity algorithm. First of all, you need to identify a Hamiltonian cycle, and none of the edges in the cycle should cross each other, so we would need to redraw the graph with this cycle on the outside. Then we choose any edge and decide this will stay inside the Hamiltonian cycle. Then we must consider all edges that cross the edge, and we look to see if we can draw them on the outside. And if so, we go to the next step. And if we can't draw them on the outside without crossing, then the graph is non-planar. And we do this with each of the edges in turn. And then we stop when all crossings have been considered. If none of the edges cross, then it's planar. And if some of the edges still cross, then obviously it's non-planar. So we're going to put the algorithm into practice. Here is a graph, and we want to decide if this graph is planar. Okay, so the first thing we need to do is identify the Hamiltonian cycle. And in this case, it is the obvious cycle A, B, C, D, E, F, A. It's really useful to draw this as we go along. So we're going to draw this cycle. Next, we look at all the edges that we haven't included in our Hamiltonian cycle. So there are 1, 2, 3, 4, 5, 6 edges remaining. So we've got A to E, A to D, B to F, B to D, C to F, and D to F. So now we take these 6 edges and we need to decide which ones go inside and which ones go outside our new drawing. So it doesn't matter what order we write them down, and it doesn't matter what order we consider them in. So I'm going to take the first one and I'm going to label it inside, and we're going to draw it on the inside. So next I need to consider all the edges that cross A to E. So that's B to F, C to F, and D to F. So B to F, so I need to put outside. C to F, I need to label outside. And D to F, I also need to label outside. And I'm going to draw these on as well as I go, because this is a useful way to check that I've done it correct. So as we can see, C to F and D to F go into the same node, but they don't cross, so it's okay. So now we need to consider some unlabeled edges. So we're going to next consider AD. We're going to label that inside. I'm going to draw it on. So A to D is inside. Then I need to consider any edges that cross A to D. So the edges that cross are B to F, but we've already considered it, and C to F, and we've already considered it. So the next one is B to D, and again we label it inside. And I want to draw it on. And I want to consider any edges that cross B to D that we haven't already considered. And obviously there aren't any, so we are finished. Since every edge is labelled inside or outside, we know that this graph is planar, and our diagram confirms that this is the case. So yes, this is a planar. So next we're going to decide whether this graph is planar. So again, the first thing we need to do is identify a Hamiltonian cycle. So we can see one here in red. That's A to B to F to C to E to D and back to A. Now we must redraw this graph with a Hamiltonian cycle around the outside, but make sure you label the vertices correctly. So now we need to draw in the remaining edges. So it's A to F, B to E, B to D, and C to D, E to F. So now again we need to list the edges on the inside. So it's all 5 of them. And now we need to consider these edges in turn. So I'm going to consider the first one, A to F, and label this inside. And it would be worth drawing this as we went along. And now I'm going to consider any edges that cross AF on our new graph. So it's B to D and B to E. And I'm going to label these outside, and I'm going to draw these on the outside. So B to D and B to E. And so far so good, none of the edges cross. So next I'm going to consider CD. I'm going to label this inside. And I'm going to draw it on the inside, so C to D. And then I'm going to consider all edges that cross C to D on this graph here. So that's F to E and B to E. B to E has already been considered, and there's an outside edge, so it's just F to E. So if I label F to E outside, and I'm going to draw it on. So F to E goes here, and I'm going to draw it on. And there we have a planar graph. So is this graph planar? Yes, it is. So is the complete graph K5 planar? So again, we're going to identify a Hamiltonian cycle, and in this case it's fairly obvious that there's one all the way around the outside. So we're going to draw this. Okay, so next we're going to list all the edges that are on the inside of the complete graph. So we've got C to A, C to E, B to D, B to E, and A to D. And then we're going to consider these in any order we like, but I'd always like to start at the top of the list. So we're going to redraw CA as an inside edge. So if we draw CA on the diagram, it's easier to draw the diagram as you go along so that we can visualize it as well, but it's not a necessity. So then we're going to consider all the edges that cross C to A, so that's B to D, so we're going to call B to D an outside edge, and B to E, so B to E is also an outside edge. So B to D, I'm going to draw as an outside edge, and B to E, I'm going to draw as an outside edge. Okay, so next we're going to consider C to E, and we're going to draw that, label that I, and draw it on the inside. So C to E gets drawn on the inside. And then we're going to look at all the edges that cross C to E. So in this case, B to D we've already considered. And then we've got AD, and we label AD as an outside edge, and we draw AD on. And as we can see, AD now crosses BE. So is the complete graph K5 planar? No. So for the planar algorithm, you must remember that it determines if a graph is planar or not. It only works on graphs that contain a Hamiltonian cycle. The edges in the Hamiltonian cycle must not cross any edge, and if it does, then you need to redraw the graph if necessary, like in our second example. The planar algorithm doesn't produce unique results, and that's because a list of edges can be written in any order, and we decide whether they're inside edges or outside edges. So this concludes our session on Planarity algorithm. Our next session will be on Floyd's algorithm, setting up initial tables.